Hello everybody, welcome to this lesson today, whereby we are going to tackle questions involving the exponential form of a complex number. So let's start out with this one. We have this one and we are to convert it we need to convert it into rectangular form. So what we know from this, that 7.2 is the modulus and that 1.5 is the argument. Okay, so if we know this, we already have our polar form. Our polar form therefore will be 7.2 1.5, or in degrees it will be 7.2 85.94 degrees. We just convert this into this will convert 1.5 radians into degrees. You'll get 85 by 94 degrees. Okay, now that we have this, we can write it in its usual long form, which is 7.2 cosine 85.94 degrees plus j sine 85.94 degrees. Okay, so if you were to open that bracket, this is what we get: cosine of 85.94 times 7.2, that is 0.51, plus sine of 85.94 times 7.2, it is j 7.2. Okay, so we have written this complex number from exponential form to rectangular form. Okay, so let's try another example. If you are given, say, 2e1 plus raised to 1 plus j pi over 3, and we need to convert this to rectangular form. So this is how we go about it. First of all, what we can do, we can use indices to separate this power. So we'll have 2e and e raised to power j pi over 3. So this and this is the same thing. We have only separated them using the laws of indices. Okay, so this part, e raised to power j, so from our knowledge from this arrangement, we know that r should be 2e, our modulus should be 2e, and our argument should be equal to pi over 3, just from this arrangement here, since this is the exponential form of a complex number. Okay, or the argument can also be given as 60 degrees, radians mode, degree mode. Okay, so if we know all that, We can now write this in rectangular form very easily. We can so let's write it in polar form first. This is 2e and 60 degrees. Okay, so what we can do, we can just punch this very quickly in our calculator by pressing shift then rec, enter our modulus first, 2e comma, our argument is 60, close bracket. Yeah, so that's our real part, 2.72. real part is that. Now for the imaginary part, you just press alpha and you press F and equals, so you get plus J 4.71. Yeah, so as simple as that, we have converted this complex number in its rectangular form. Okay, let's try another one. Let's try, given that z is equal to 3e raised to power 1 minus j, and you're told to find natural log of z in polar form. Z is equal to 3 exponential raised to power 1 minus j. Find z, natural log of z. Find natural log of z in polar form. So ln is this natural log of z. That is the question. Natural log of z. Find it in polar form. So first of all, we need to use laws of logarithm here to separate this. So this will be natural log of 3 plus natural log of e 1 over j. Laws of logarithms. We have used laws of logarithms to separate this. Then we can use laws of indices to further simplify this. We can continue using laws of logarithms to simplify this. So natural log of e raised to power 1 minus j, we can bring the whole of this in front like this, 1 minus j, natural log, bring the power down, natural log of e. Okay, we have brought the whole of this power down using laws of logarithms. Okay, so what we now have is natural log of 3 plus 1 minus j. Natural log of e is 1, so it remains like that. Natural log of e is just 1. So what we now have is that, so all we need to do now is find natural log of 3. You can punch that in our calculator and we are done. Let's do that. Natural log of 3 is 1.09 plus 1 minus j. So the real part, this is 2.09 minus j. And that's it. We have written this complex number in rectangular form. Okay, thank you for watching. This is Understanding Math.